All right, good morning, everybody. Hopefully you're working your way through the exam review. Remember, that's going to be due Wednesday by 6 p.m. And it's going to be 10% of your final. I'll talk about that again here in a second. Just kind of review what's going on here. So Friday, we got 7:30 to 9:30, all graph and calculator. If you could print it out and do it on there, that just is very helpful for me to grading. You may write any identities and formulas on the back and front of a 3x5 index card. Okay, no example problems. Upload by Thursday, 11:59. And that's going to be, let me see here. If you go to under the final exam, it'll say exam review card. And it better have an upload spot there. And let me just double check here. I may not have turned that on yet. Submitting nothing that's published. I do need to edit that. So I need to make sure you can submit something here. And so that you can upload that card. And that will be not graded. And hold on. Let's see here. Yep, I'm going to have to switch that so you can upload it somehow. So I will do that when I'm done with this. So upload by Thursday. Remember, this is 25% of your final grade. Look up your Stark Straight grade. It's on the modules there. And now here's my goal is that the exam is 120 points. I'm still finalizing a couple things. So that means the review is 12 points. And so that gives us a total of 132 points. And in the end, basically, I will report your score as a percent. So when you see it go in the grade book, I don't know if you missed 15. Okay, so that gives you 117 out of 132. And then it'll go in there as and actually usually, an 88%, okay, for that. And so that's how you're going to see your grade when we're done with this. There will be 10 to 15 just true, false, always, sometimes, never short answers that are just not directly from the exam review. So these are just your general knowledge of understanding how to do trig and everything for the second semester. So just know that. All right. Is that it? All right. Again, our weekly schedule here. Today we got a Canvas conference, and the Canvas conference is more just you need to come in. What do you have questions on? If you want to email me something ahead of time so I'm ready, that is fine. Wednesday, again, and Thursday, no videos, but Canvas conferences, it's your normal times. And then Friday's the exam. All right, let's go through some problems here. These are not direct problems from the review, just kind of give you a guide. And if you, like I said, if you have questions, make sure you're showing up. All right, tangent of theta equals, you don't need to see me anymore. Tangent of theta equals 12 over 5. Theta's in quadrant 3. Find cosecant. Well, we know cosecant is the flip of sine, and so it's going to be hypotenuse over opposite. Now, this is not the unit circle. Okay. And so since tangent of theta is 12 over 5, tangent is opposite over adjacent. So that's 12 and 5. Now, technically, they're negative, but we know tangent's positive in quadrant 3. We need to find this value right here. And so we do, and I can drop the negatives for this. 5 squared plus 12 squared equals x squared. 25 plus 144 equals x squared. 169 equals x squared. Square root of 169 is 13. So that value is 13. Cosecant is hypotenuse, which is 13, over opposite, which will be negative 12. Be careful here. You do have to include the negative here. And so in the end, cosecant is negative 13 over 12. Okay, for that. So just kind of making sure you understand. Remember that most of what we did in this whole chapter or whole second semester was dealing with trig. All right, solving equations. Find all solutions over the interval 0 to 2 pi. That means we are in radians. So sine 2 cosine squared minus 3 sine of x minus 3 equals 0. When we got a squared and we got a linear term, it's just like when you have like x squared plus 6x plus 8 equals 0. We want to think factoring. Okay, you want to think factoring. But we have a big issue. You have a cosine squared and a sine. You got to have the same function. You can't have a cosine and a sine. But we know that cosine squared is equal to 1 minus sine squared. So we're going to have to take out the cosine squared and put in 1 minus sine squared. So 2 times 1 minus sine squared x minus 3 sine of x minus 3 equals 0. All right, well, I'm going to have to do a little bit of work. Distribute the 2. And then I'm going to combine some like terms. And so it's going to give me negative 2 sine squared x minus 3 sine of x. And then I got a positive 2 and a negative 3, which gives me a negative 1 equals 0. I always preach I like to have my first term positive. So you can move everything over the other side, or you can multiply everything by negative 1. But whatever, I'm just going to flip all my signs. So I get 2 sine squared x plus 3 sine of x plus 1 equals 0. And now I'm going to factor this. Now, if you want to, you can think of this as 2x squared plus 3x plus 1 equals 0. If that's how you need to think of it to factor, that's fine. But these last two numbers have to multiply to 1. And my only choices are 1 and 1. And then you can just kind of go through here and just verify 2 sine of x times 1. And it's 2 sine of x. 1 times sine of x is sine of x that adds up to 3. So this works. And now this becomes 2 sine of x plus 1 equals 0. Sine of x plus 1 equals 0. Subtract 1 divided by 2. And now just be careful because sometimes you make that mistake and you accidentally put the wrong sign. And you just lose careless points, so just be careful of that. All right, sine of x equals negative 1/2. Sine of x, you are allowed to use your calculator for this whole thing. Your answer does have to be in radians. I would suggest that you make sure your calculator is in degrees the whole time. And now if you look here, I'm also on that fourth one, I'm also in polar. I would go back to function just because it's probably going to be more useful. I would keep it in degrees. You can in second. Inverse sine negative 0.5. Now it gives you negative 30. You cannot give me a negative angle between that negative 30 degrees. Remember, that's the same as 330. So where is sine negative at? It's going to be negative in quadrant 3 and 4. My reference angle is 30 degrees. That's going to be 330 or 11 pi over 6. And this is going to be 210 or 7 pi over 6. You have to write your answers in radian format. So that's what we get there. And then where's the y coordinate equal to negative 1? Okay, that's going to be right there at, you think unit circle, it's going to be 270 or 3 pi over 2. So in the end, I got 3 answers: 7 pi over 6, 3 pi over 2, 11 pi over 6. Okay, so then we're done with that one. All right, I don't think on the review I have one with a sum. I have a double angle formula. I don't know if I have a sum or difference. I just want to make sure that we do one of these. So let sine of u equal -3/5 and cosine of v equal 12 over 13. This tells you what quadrant we're in. So it's between 180 and 270. So it's in quadrant 3. This is between 270 and 360, quadrant 4. Find the exact value of sine of u plus v. Well, this is our sum or difference formulas. And don't forget sine of u plus v. It's the sine of the first one times the cosine of the second one plus cosine of the first times sine of the second. Well, we know sine of u and we know cosine of v, but we don't know cosine of u or sine of v. But we can figure those out easy enough. All right, that's u is in quadrant 3. It's -3/5, which means opposite is 3 and the hypotenuse is 5. And then if you do Pythagorean theorem, we're going to end up with 4, just to save a little bit of time. And now, so this is u. V is in quadrant 4. It is 12. Cosine is 12 over 13. And if you do Pythagorean theorem, again, what are we going to do get here? We're going to get 5, okay, because you're going to get 12 squared. Whoops, that's a square. Plus y squared equals 13 squared. Y squared, and when it equals 25, you get 5. And so this is v. All right, so now sine of u plus v. I'm just going to rewrite sine of u times cosine of v plus cosine of u times sine of v. Well, what's sine of u? We already know that, don't we? Sine of u from up above there, -3/5. Now remember, it is not this. The whole thing gets replaced with -3/5. Cosine of v is 12 over 13. Plus cosine of u, which is going to be, in this case, remember that's a negative. And this is the biggest thing here, is dealing with the negatives, is making mistakes there. So that's -4/5. And sine of v, and that's going to be a negative there because it's in quadrant 4. That is -5 over 13. -3 over 5 times 12 over 13. -3 times 12 is -36. That's 65. And then negative times a negative is going to become a positive. So this sign is not going to get altered. And it's just going to be 20 over 65. And now -36 plus 20 will give me -16. So that's what we get here. So sine of u plus v will equal -16 over 65. Okay. So understanding, make sure signs are the biggest issue dealing with these. Either you forget to put it down, you just make a mistake in your multiplication. Really double check what your signs are. All right, next one here. Sine of theta equals 2/3. Find the exact value of cosine 2 theta. So that's a double angle. I'll tell you now, there will be no half angle problems. Do not worry about those. They're not on the review. I'm not going to do them on the video. No half angle problems. So you don't even need to write those down unless it makes you happy. But they're possibly sum and difference, possibly double angle. Well, you got to look. There's actually, remember, there's 3 equations for cosine of 2 theta. And so on your identity sheet, if you take a look at that one, that's cosine squared theta minus sine squared theta. And so we know the sine of theta is 2/3. If they don't tell us where it's at and it's a positive, we got to go quadrant 1. So that means opposite is 2, hypotenuse is 3. So 2 squared plus x squared equals 3 squared. 4 plus x squared equals 9. X squared equals 5. X equals square root of 5. That'll be the case right there. So cosine of 2 theta equals cosine of theta squared. Well, cosine of theta is going to be adjacent over hypotenuse, quantity squared, minus sine squared, which is 2/3 quantity squared. Well, that gives me 5/9 minus 4/9. So when I'm done, cosine of 2 theta 1/9. Okay. Exact form. These are, make sure no decimals, especially if you end up with a radical. Okay, especially if you end up with a radical. In these cases here, in this one, in the previous one, we ended up with no radicals, but fractions. So it's a little bit easier, but just remember that for on the test for that. Okay, we're going to go through a good bit here today. Might be a little bit longer than the one from yesterday, but I'll make sure you get through as much as we can here. All right, find solutions in the interval 0 to 360. Round answers to the nearest 10th degree. All right, the main thing about this one is you can use your calculator. Your answers have to be positive, but inverse sine of negative 0.35 gives us a negative answer, first of all, and you have to know that there are also 2 answers in the interval 0 to 360. So remember, where is sine negative? It's negative in quadrant 3 and quadrant 4. The inverse sine is negative 20, nearest 10th of a degree, 20.5. That's right here. I'm not even going to put the negative in there. I'm just going to use that as my reference angle. So the actual answer is going to be 360 minus 20.5. That means this is also my reference angle. This is going to be 180 plus 20.5. So my 2 answers are going to be, that's going to be 200.5 degrees. And this is going to be 339.5 degrees. As you got to know, it has to be positive, and you have to list all answers. There's going to be 2 answers for all of these unless it's a 1 or a negative 1. All right, cosine of x equals negative 0.72. And let's do this here. Cotangent of x equals 6.25. All right, see what you guys come up with. I'm going to pause it. You see what you come up with. See if I can actually get to here. Okay, coming back here, and I'll go over how to get these just to double check, but I got 136.1 degrees and 223.9 degrees for number 2. And then the third one, I got 9.1 degrees and 189.1. So for inverse cosine of negative 0.72, we get 136.1 degrees. That's what our calculator gives us. Well, that's going to be in quadrant 2. Cosine is also negative in quadrant 3. Here's typically how I'm going to do this one is that's 136.9. That means that angle there, that reference angle, is going to be 43.9. That means this is going to be 43.9. And that means the second angle I get is going to be 180 plus 43.9 degrees. That's where I get the 223. Those are both positive, both between 0 and 360. All right, this last one here, whenever you have like secant, cosecant, cotangent, and we do it, this is one that causes people the most issues, okay? Because you have to do tangent of x equals 1 over 6.25. Okay, you have to do tangent of x equals that. Because I think a lot of times people will do this, will do 1 divided by tangent of 6.25. They'll do it this way, and sometimes that won't give you, well, that one will work in this case, but when you do it with secant and cosecant, like if you do 1 divided by cosine of 6.25 for secant, it's not, how did that work? Okay, cosine, let me see something here. Oh, I didn't do inverse cosine. Inverse cosine. So if you do 1 divided by inverse cosine, that's the problem, because that's not in our domain. It'll give you an error, but it's really not an error. It does work. So you have to do this first. So tangent of x equals 1 over 6.25. And so we do inverse tangent of, let me clear all that out, inverse tangent of 1 divided by 6.25. And we get 9.1 degrees. Well, that's going to be in quadrant 1, and it's also positive in quadrant 3, which is going to be 180 plus 9.1 degrees, and that's where we get our second angle. So if you have secant of x equals 6.25, you have to make that cosine of x equals 1 over 6.25. Okay, make sure you be careful there. All right, vector problem. We spent a lot of time on vectors. And you'll just make sure, so you're going to have one in here dealing with a plane traveling, which we did a lot of with bearing and direction. And we got one here with 2 vectors pulling, or 2 tractors pulling on a large tree stump. So in this case here, we're going to convert these to IJ form, add them together, find magnitude and direction. All right, one with 560 pounds in a full direction of 220 degrees. That would be, let me see if I can do something here. That would be this red vector. That would be the 560, because that would be 220 degrees. And the other one with 650 pounds of force with a direction of 110 degrees. So that would be 650. So it looks like here, and I don't have it drawn exactly right, but it looks like the resulting vector should be somewhere in quadrant 2. Well, we'll know for sure when we do our work. Well, I'll let u be the 650. So vector u is going to be 650, remember, magnitude times cosine of the direction, which is cosine of 110 degrees, plus sine, or 110 degrees I, plus sine 110 degrees J. And then we'll figure what that is in a second, but V is going to be 560 cosine 220 degrees I plus sine 220 degrees J. We'll go ahead and nearest 10th. We got everything to nearest 10th. That's fine. So on your calculator here, it should be 650 times cosine of 110. And so we get negative 222.3. what was that? Negative 222.3. 0.3i, and then I got 650 sine 110, and that's 610.8j, so plus 610.8j. All right, V, go ahead and figure out V. Write that down. So take 560 times cosine of 220 and 560 times sine of 220. And you should get negative 429.0i minus 360.0j. Now we got to figure out, let me go do this here. And so now I need to figure out what u plus v is. U plus v. And so you add negative 222.3 and negative 429.0. Minus 429. And then that gives me negative 651.3i. And then I take 610.8 minus 360. And I get 250.8 positive 250.8j. This is the endpoint of the vector. Negative 651.3, positive 250.8. That would be so that means it has to be in quadrant 2 because it's a negative and a positive. So that gives me like a position vector. Well, now I got to find the magnitude to get the total force, and then I got to find the direction. So I'm just going to plug in negative 651.3 quantity squared plus 250.8 quantity squared. And what am I going to get here? Negative 651. I'll take the square root after I'm done here. Squared plus 250.8 squared. And then I do second square root, second answer. 697.9 pounds. So 697.9 pounds. All right, now don't forget, when we do this next step, we are finding the reference angle. You take the inverse tangent of the absolute value of the y, the j, the vertical, over the horizontal, and that'll give me the reference angle. I'm just going to drop that negative. I'm going to do inverse tangent 250.8 divided by 651.3, and that gives me 21.1 degrees. That is this reference angle. So we are in quadrant 2. That is 21.1. So the actual angle is going to be 180 minus that. So that means the direction will be 158.9 degrees. So magnitude, that is going to be 697.9 pounds, and the direction is going to be 158.9 degrees. Okay, so vectors. Use de Moivre's theorem to find each power of z. Write answers in rectangular form. Okay, section 7.6 and 7.7 we did not quiz or test over. We did 7.1 through 7.5. We covered these. I told you it would be on the final. I'm going to be a man of my word. Okay, so we did not. So you might need to go back and review this a little bit. 7.6 and 7.7. There's also some additional problems on the review. Okay. Well, de Moivre's theorem. Okay, how do I figure out a power of a polar? Okay, this is a polar form, polar coordinate. Remember we said if z to the n power. Okay, so if z equals r times cosine of theta plus I sine of theta, then z to a power is r to that power cosine of n times the angle plus I sine of n times the angle for that one. So we'll call that z, and then we'll take z to the 8th. Well, z to the 8th is going to be the square root of 2 to the 8th power cosine of 8 times 60 degrees plus I sine of 8 times 60 degrees. And then what is square root of 2 to the 8th? Well, square root of 2 is 2 to the 1/2 to the 8th power. 8 times a half, and we multiply those, would be 4. And 2 to the 4th power is going to be 16. So that's going to be a 16. Cosine of 8 times 60 is 480 degrees plus I sine of 480 degrees. Now we want it in rectangular form. This is polar form. Also want it in exact form. Anytime we do this, we're going to keep it exact as long as we have unit circle angles. Like I said, if this ended up being like 12 degrees, we could have to use a decimal. All right, what angle is coterminal with 480? Okay, I'm just going to subtract 360. That's just 120 degrees plus I sine of 120 degrees. And so what is cosine of 120? Okay, so go over here if you need to draw it out. That gives me a 60-degree reference angle. And the cosine, since that's in quadrant 2, that's going to be -1/2. And then the sine is going to be positive square root of 3 over 2. Distribute your 16, so z to the 8th is going to be -8 plus 8 square root of 3i. Okay, -8 plus 8 square root of 3i. So that's in rectangular form. So I want to at least cover something with the polar form. Make sure you review that really good. All right, we are going to do 2 more. Determine the matrix. So this is pretty fresh. So if you got a 3x3 matrix, remember what we did here: 3, -2, 1, 7, 6, 1, x, y, 3, -2. We copy down the first 2 rows, and then we go, okay, from left to right. And so that is going to be -2x along that diagonal plus 7y. And that looks like it's going to be plus 18 minus. Then we go along our diagonals this direction. And it looks like I get 3y plus 6x minus 14. Now just be careful here with the math. So -2x plus 7y plus 18 minus 3y minus 6x plus 14. Combine like terms, I get -8x, I get plus 4y, and I get plus 32. So that's your determinant. Nothing else you can do with it. You're all good. All right, so that's your determinant of a 3x3. Kramer's rule. Okay, now again, the situation, I'd use this as well as what we did on your last test. Instead of, you don't need to find them all. You can just find one. I know you know how to do it. So let's say we're finding z. Okay, So to find z, that equals d sub z over d. Now d is the determinant from your coefficients. 1, -3, 2, 2, 4, -3, 3, -2, 5. And d sub z is you take the coefficient or the constants and they go in for the 0. So it'd be 1, -3. I'm just going to do the first two. 2, 4, 3, -2. And then in the 0 there, your column, 9, -9, and 12. Well, now it's just a case of, oh, wait, what am I solving for? Solving for y. Oh, crap. So that means this is d sub y. This is d sub y. I have to fix this. And so we put the 9, -9, and 12 here, and those will still stay your coefficients of z, 2, -3, 5. And since you are allowed to use your calculator for the whole thing, I would definitely plug this in. So second matrix, edit. So it is a 3 by 3 for D, and I have 1, -3, 2, 2, 4, -3, 3, -2, 5. And second matrix, and go to math, determinant, and it was matrix second matrix, whoops, and then hit enter, and then determinant of A is 39. All right, just save a little bit of time. That's going to be -78. So y equals d sub y divided by d, which is -78 over 39, which gives me -2. So that's your value there. Y is -2. Do not give me what x is. Do not give me what z is. All righty. Best of luck to everybody. We'll have some campus conferences. Yeah, I don't know if you'll get this before Tuesdays, but then we also have Wednesday and Thursday exam on Friday. All right, and take care.